Hello once again to the World Wide Web. Nobody calls it that anymore, but that's still stuck in my brain. Every time I see www, I'm like, I wonder how many people these days, especially those of you born after the year 2000 or so, maybe 2005. I'm not exactly sure where the cutoff point is, and people stopped calling it that. But anyway, I'm back with more of Odinmade Hero, the programming series where I work through Handmade Hero by Casey Muratori one day at a time. While he does it in C and C++, I'm doing it in the Odin programming language. And so today is kind of a special day. It's the last stream of the year for me. And it'll be the last stream in this format where I'm kind of coding side by side with Casey. It's been an interesting experience, which is, a very vague way to put it, but I don't really know how to put into words what doing the stream has done for me, and just in terms of thinking about things differently. And obviously, like, I'm learning game programming concepts and stuff here on stream, but it's just been it's been a whole lot more than that for reasons that I really, again, I don't know how to explain. But it's been fun. I've appreciated everybody who's stopped by in the chat to kind of just see what I'm doing and talk about, whatever random topics come up as I'm working through the series. It's been a wide array of stuff, including programming, industry topics, and just life topics, and that and all those sorts of things are a big part of the reason why I decided to stream it at all, right? It's to be able to have those conversations, because that is like the human element that I feel is so often missing from programming. So much of programming, I feel like, does not respect people's times or respect people in general. Not programming, but like software, I guess I should say. The output created by programming, right? And it's hard to say whose fault this is. If it's anybody's fault, I don't know that it is. It just kind of is what it is. And I guess that's all I can really say about it without completely making no sense whatsoever. So with that being said, we're going to do day 82 here, which is titled Caching Composited Bitmaps. And this is kind of the tail end of, well, this is kind of starting a new thing, because we did a bunch of we did all this entity collision detection change to reconcile the fact that we are a 2D game in 3D space. But in the last stream, we started pivoting towards more rendering stuff, and so now we're just kind of splatting all of these textures on the ground here, which is chugging up the frame rate quite a bit. Also because I used a slower switch with the compiler, just so I could more closely mirror what Casey is doing, because he's just using the what is it, -OD to the what is it, the Clang compiler? I can't remember what compiler he's using, or is it? No, because it's Microsoft's compiler, so I think it's CL. It's something like that. Point is we're trying to do things as closely to his environment as we can, just so I could see the changes that I'm making affect things in similar ways. So when we do speed up the draw code using SIMD, eventually we'll get to see those same benefits as well, especially as we start adding more and more stuff to the screen. So we're going to go ahead and kick off day 82, and then we'll see what happens. So when we get to day 83, I think I'm just going to work through that code in advance, and I'll try and take notes, and then I'll still do a stream, but it'll probably be a shorter stream where it'll still roughly come out to about an hour, but I'll just kind of talk about the lessons that were learned Any interesting topics that came up, I'll make note of them and then try and cover those on stream. And as well as the code, anything that was interesting in the code, I'll try and make note of it. Things that I didn't quite understand, try and just get a deeper level of understanding coming out of each day of Handmade Hero, rather than coding along side by side, which has its own there's merit to that, but the trend over the last 20 or so days for me has been this is just not, it's not as rewarding as it was, for the first however many days, 30 days before that, right? Where it felt like when I got stuck on something, there was a meaningful outcome when I figured out what I was stuck on later. So hopefully that all makes sense. With all that being said, I'll let Casey kick it off.
There we go. Hello, everyone, and welcome to Handmade Hero, the show where we code a complete game live on Twitch, on the air with no engine and no libraries. So really, you could say that this is the whole package. This is the complete game. This is every last little drop of gaming goodness. Nothing hidden, nothing squirreled away, behind the curtain. It's all here in the raw. And what we did yesterday, due to the fact that there was a regrettable incident on the train, is we decided to do something lighter and fluffier than we had planned on doing. So we decided to do some work on ground rendering and play around with that a little bit. And so what I would like to do today is just maybe finish up a little bit of that ground rendering, because we were kind of having fun with it yesterday. So we'll just finish that up maybe today and do a little bit, maybe clean up tomorrow. And then next week we'll start back on collision detection stuff that we wanted to clean up. Really, it's collision detection logic that we were sort of working on, where the ground was, that sort of stuff. So let's go ahead and do that. Before I open up the code, I'd just remind everyone that if you are trying to follow along at home and you pre-ordered the game on handmadehero.org, you should have gotten a link in your email. That link has a zip file in which you will find all the day's source codes. And if you look, today is day 82, so you can unzip day 81's source code if you want to play around with the same stuff that I am playing around with today. You'll be at the exact same point that I am. So let's take a look at where things were. So if we go ahead and run this here, I think where we stopped, we just kind of made a little thing that would splat out the ground there. You can kind of see where it is. We're still drawing some things in there like our room boundaries. I suppose we should probably turn that off. But the other thing that I pointed out was because we didn't have any optimizations on our bitmap lidding, it gets very slow to put that background in there, right? So that's something else that we can kind of think about a little bit. So you know what, I'm going to go ahead and just turn off those debug boundaries since we don't care about those at the moment. I'll go ahead and toggle those off. Let's see here. So we've got draw rectangle calls where we're drawing those. Let's see here. Actually, I think it's push rectangle calls, where we were sort of putting those boundaries in there. So we had our push outline, so this right here. We really don't want to do that at the moment because I don't really want to see those blue lines. Those are just there for our debug purposes, so I'm going to get rid of them, and so we can just look at the stuff that wasn't the blue lines. So I guess what I wanted to kind of do here is I wanted to kind of take a look at, first of all, I sort of suggested when someone in the post stream had said, well, what would we do when we want to start speeding this up? I was saying, well, I'd probably do something where we would have some kind of backing tiles where we would draw the background once and then just split out of that, so that the constant sort of splatting of things that we use to make these patterns wouldn't be causing a huge problem in terms of performance every frame. We'd just do that compositing on the fly in little sort of sections. And so that's something that we could consider playing around with. That kind of sounds like a fun thing to do. The other thing that it would be that we kind of need to figure out how to do is, well, if we want to have multiple layers of things, which is kind of where we started down this, why we started down this path. If we want to have multiple layers so that there's an upper floor and a lower floor, like we were kind of doing here, because remember we still have this sort of notion of 2 floors worth of content there. You can go up our sort of virtual stairwell here that we have no graphics for yet. If we wanted to make those 2 different floors and start to think about where these things go, we need some concept of that, right? We need some way to make that work. So that's sort of one thing that we should probably think about. And like I said, I'm not 100% sure what it is that we really want to do. So that's on the table. What I'm going to start with, because it's the easiest thing, is just cleaning up the random number situation a little bit, right? So I'm going to clean up that random number generator situation just a tad, because I kind of said we should probably do that at the end of the stream before, and we left it sort of in a bit of a nasty state. You can see I got this to do right here, make random number generation more systematic. So I think I'm going to take a second just to do that. And again, this will also set us up for later on when we want to actually talk about random number generation, where we replace this random number table with an actual random number generator, which would be good. So you can see there's really no code right now in the random number generator. It was just a table, and we were just...
So this is probably a good example of why it kind of makes sense to change the format of the stream a bit. We've already got a good random number generation system in place because I'm just using Odin's RAN package, right? I'm not really sure whether to call it like a module of the math package or a sub package of the math package. But anyway, it does everything we want it to do. And then some. It made it a whole lot easier than doing it strictly Casey's way. And again, the reason why he's doing it all this way is to show actually how you get from point A to B. We're already at point B because we have all this great stuff baked into Odin standard library, right? And there's all sorts of other great stuff in there that just makes it easy to go and do the thing, but it's still obviously valuable to understand that we stand on the shoulders of giants, right, to be able to get all this great stuff. So but in this case, it's like we don't necessarily need to see all of this. If the information is there in the series, if you want to go and watch it, go and watch it. But I think the point for me of this stream should be to take what am I specifically getting out of this and applying it in the direction that I want to go in. Because one of the things that I've brought up a bunch of times here on stream is that games programming is such a wide and very general field. Not games programming specifically, but games in general. There's so many like disciplines within games that all come together to make a game, right? How do I take the things out of Handmade Hero that are interesting to me, that help me go in the direction I want to go in? Those are the things that I want to try and capture with the stream if possible.
Sampling directly out of the table. So what I'd like to do is I'd like to pull out this code that we've been using many times, and I'd like to turn it into something that I can just use anytime I want. Again, straight up compression-oriented programming here, just trying to condense down some of these things that you've seen happening a bunch of different times. So what I'd like to do is introduce the concept that people can have a stream of random numbers that they can access, and make some of these ways in which we're using them. Like down here we were trying to get a number between 0 and 1, for example, and then we were turning it into a number between -2 and 1 and all that sort of stuff. I'd like to sort of make that stuff more systemic so that when people want to use, and by people I mean me, but when we want to go use the random number generator to generate randomness for us, we will be able to easily get the types of randomness we want out of it without having to think through the math every time, right? So what I'd like to point out, first of all, is that we don't typically know up front very much about how the people want to use these random numbers, right? Sometimes when you want to use random numbers, you would like them to be sort of effectively random, right? So when you're asking for a random number in the code, sometimes you want it to be really completely random, or at least as close to that as possible, or indistinguishable from random, et cetera, et cetera. But other times what you want is a series that has the properties of randomness, but that actually is completely predictable, right? And the reason that I say this is because if you think about how we might want to do things, let's suppose that we generate a whole world, right, out of randomness. So we're going to create a random world for the player to play through. But we would like the player to be able to send some small piece of information to his friend that friend could enter into the game on their computer to play through that same random world, right? And now the random world we generated might have been hundreds of megabytes worth of stuff, but we know that it all came from this one stream of random numbers. So we would want to be able to send just one little piece of information that's like, how do you reconstruct that stream of random numbers so that you don't have to send that whole thing across, right? And that is typically what's called the seed, right? It's called the seed because you start the random number generation with it.
And like if you've done almost any amount of programming, you'll have seen something to that effect before, right? But that's what I'm doing here at the top of the game update and render loop. Just resetting the seed to be this random, power of 2. At least I think that's a power of 2, if I'm not mistaken. And it just, sets the seed. So that's all he's talking about here, right?
And basically what it is, when we get up to real random number generation, that's the number that you start out with to start running through the permutations that the random number generator does to produce a series of random numbers. And of course, it's always pseudo-random, really, because they're not random if they're reproducible like that. And so you can think about that in terms of our random number table pretty easily, actually. Because really, in our case, what the seed is just what number in the table you started on. So for example, if we wanted to pick a random series here, we would just say, oh, start on number 35 or whatever, and just keep reading sequentially right through there. That would be our seed. Because that's the only real control we have over where we get in the sequence. Now we could have a little more information. We could say, for example, what index we're going to start on and how many numbers to skip each time or something like that, right? So go by 2s or go by 4s, right? Something like that. So you can imagine different ways that we could construct our own notion of a seed for our random number table. But for the time being, we don't really have to care too much about that because we're not doing those sorts of things. But I wanted to bring it up so you'd understand the concept of it because it is something that will come to play later when we want to do fancier things with the random number generator. And what that motivates for our design is that I want to have a way, because looking at, this is just my experience as a programmer speaking. We haven't seen this become necessary in the code right now. It's just my experience saying, hey, look, we want to do this, trust us, it'll save us time later. My experience says that generally what you want to do with random numbers is you never want people to just grab random numbers. You want them to basically have some handle that they use to get random numbers, so that that handle can track a particular stream, so that you can have multiple streams of coherent random numbers in your program, some of which might be actually things that are supposed to appear random on that playthrough, like particle effects and whatever, and others might need to be controlled randomness, that's producing a repeatable series on multiple people's machines at the same time, so that you can do things like send those seeds across and that sort of thing. And that's something that you probably would have seen in, like, I think even the new Binding of Isaac Rebirth. I don't actually know for sure, but I think in the new Binding of Isaac Rebirth, they do things where you can basically like enter a seed or something to start playing, right? I think I think this kind of thing has been sort of exposed to users in the past. It's not, it's not an unusual thing, right?
Or like the one example that I can think of with games off the top of my head is when you're generating a new Minecraft world, right? You have a new world seed or whatever, right?
To think about. So what that means is I want to transform this code to start thinking in terms of some kind of a handle, right? That's like a random series. It's some series of randomness. And for our purposes, all it's really going to be, you can see it here, we've got this random number index. All it's going to be is that index, right? It's just going to be that index that we need to pull stuff out. But later it might, not mean that so much, right? So when we draw a test ground, what we'll do is we'll just initialize our random series. So we'll do series equals, and we'll just say like, oh, we'll seed it with 0 because that's what we seeded it with before. Or we could seed it with whatever, 1, 2, 3, 4, it doesn't really matter. And we'll just assume that the seed call produces a random series, starting with whatever the seed that was input. Somehow it generates a random series out of that. And any time that anyone, anywhere in the world, for any reason, running Handmade Hero, creates a random series with that seed, we expect the series to be the same. And in this case, if it's just going to become that random number index, that's what it will do, and so that's fine, right? So then once we have that, we don't have to do this anymore, because we'll sort of assume that that'll get taken care of inside the thing. And then I just want to pull out the things that we were doing. So here's one of them, right? We've got random number table, and then we did a mod by 2, right? So we're getting one, and we're doing some kind of a mod. And what I'd like to call that basically is random choice. We're making a random choice here, right, between things. So I want to pass that random series. And then I want to say I want to make a random choice where you pick one out of 2 options. So I'm just going to pass the 2 options, 0, 1, whatever, right? And then when I come down here, I see this other way that we were using it, right? We had this one in here where we were basically doing a random. I'm going to call this random unilateral, right? And so I'll explain what I mean by that in a second. So by the way, this is going to be, I guess this is going to be a random choice. So we'll call this random choice. And that's going to take the random series. And then it's going to take the choice count, like so. And I guess this could really be unsigned, because we're not going to support negative numbers in there. And that's what we were doing here, so that way when I implement this, we'll know. And then similarly, we had one here that was going to basically return one floating point number, right? And it's returning a floating point number between 0 and 1, right? That's what this was doing. So it doesn't really take any inputs, it just returns between 0 and 1, and that's a useful thing to have it do as well. Now, the interesting thing about this, the reason I said random unilateral, is because
I don't want to keep on belaboring things that maybe aren't worth talking about, but the thing to note, I think, about what he's doing here with creating a series, right, is that he's getting a handle to it so that he can do other things with it, whereas here we've just got this kind of naive idea that we're going to reset the randomness seed, but what's missing here that is kind of it's this transparent thing happening where the context, the Odin context, has a random generator on it, right? And we can go here and look at the, or maybe we can't. Can we look at the context? How can I do this? I really just want to see the context struct, right? But for some reason I can't go to definition of it. Well, yeah, I would need to find, is there like a new call in here? I can't actually do it with new either. Anyway, the point is that on Odin's context, that handle is kind of there to be able to do stuff like this by default, right? And I might be getting some minutia about this wrong. Where's oh, this is it right here. So when we go to call, int max with some random value that we've arbitrarily specified here, that's all happening with one series. We could have multiple series by getting a handle to one. We could basically do what Casey is doing by getting a handle to a series that isn't specific to whatever the context is that's being passed all the way down to this draw test ground call. We could pull that out and make it its own, individual thing, right? But then I'd have to look up exactly how to do that. right? But it would basically create, you know, an individual series, like, or a generator, I guess, would be maybe what that struct would be. We can go and look at it and see. And that's on the runtime package. So maybe that's not quite right, but I think that's basically what he's driving towards here, right? So that way we could have, and the point of doing that is of having that handle, instead of just using the context random generator, would be that we could have multiple series that are each, you know, have their unique seeds, because maybe we don't want to use the same seed everywhere, right? But just for the purpose of what we are doing right now, right, we're just setting not the global seed per se, but the context random generators seed. So at some point, even when it ever happens, I don't know that it will over the course of this series, but if I had another use case to have a different series that had a different seed, that's the road I would start going down. But we kind of already have that, so we don't need to go and implement it. I would just have to figure out the Odin specifics to it. And that's, you know, again, why I don't really have to do anything here. Casey's just doing something that I get for free out of Odin's standard library.
I like to separate my random numbers, and again, this is just experience talking here and the way I like to do things, is I like to have random unilateral and random bilateral. And what those are is 0 to 1 unilateral, -1 to 1 bilateral, right? I don't really know where I picked up that terminology.
I wonder if the RAND package actually has something like that. I don't know that it would be called that. I guess the thing to do here would be to add, or not add, but let me bring up a tab for Odin's packages and see if maybe, well, I mean, I guess we could just jump in here and look for, like, yeah, bilateral, unilateral. It would be, it probably wouldn't look like that. Yeah, it probably makes sense to just go look at the documentation. I don't want to get too sidetracked with this, but like, rather than having to implement a procedure that goes from 0 to 1 ourselves, I would wonder if maybe Odin just kind of has something like that that can normalize randomness between either 0 and 1 or -1 to 1. Yeah, so let me yeah, this is fine. Let's just look and see in this big list of procedures here. I don't see anything that obviously does that, so we could implement it ourselves if we wanted to. I don't know how worth it is. He's putting this in random. Yeah, specifically when calculating the offset here. That could be something that's worth doing. I don't know if it really needs to be its own file, but I'm just going to do it just because I should write some code. I don't know if this is just going to be a stream where this is all he does, so I should do something, right? So I'm not just replaying his stream and doing absolutely nothing myself, just watching. Yeah, so I think at a minimum we're going to need rand. And we can worry about maybe taking a generator or a series, whatever we, you know, need to call it. We can worry about taking a handle to 1 later. For now, we can just use whatever's on the context. And yeah, I think it's literally just going to be that simple. it'll be something like that. Right? I guess max random value ought to be defined in the random file. Why not? And then, so this bilateral would be -1 to 1, but unilateral would be 0 to 1, so we wouldn't need this here, I take it. And then we'll just make those calls in here, it seems like to me. Yeah. We'll see exactly how Casey does it.
In fact, I guess you could also call it random normal and random binormal. Might be another way to do it. So, you know, a normalized number is 0 to 1, and a binormal number -1 to 1. You know, that's pretty good too. I'm not sure.
I guess I did not check to see if there was binormal and normal. Yeah, there's nothing like that. I wonder. Creates a slice of int. No. Read. It reads a byte slice with random values using the provided random number generator. No. Set global seed, int max. Yeah, these are all just like getting. There's some really interesting stuff going on in here. Gamma. I don't even know how to pronounce this. Cauchy Lorentz. Using the Cauchy Lorentz distribution. Yeah. Something tells me I'll probably never have a use case for that, but it's neat that it's in there. Yeah. Kind of seems like we're not going to find that, but it seems like it might be a common enough thing, right? Odin looks like C++. Is it just a library? No, Odin is a whole programming language. It's a procedural programming language that is honestly a lot more like C than C++. But you can definitely see C and C++ are so similar in many ways, right? But C++ has all of these added things that C really doesn't, and Odin is more minimalistic in that sense. You know, there's no templates, there's no classes, there's no methods. So yeah. But obviously there's tons of inspiration that you can see in the syntax from C. And I guess I didn't realize this before, but I just recently saw that, you know, Odin is also heavily inspired by Pascal, and I guess Pascal has a begin and end syntax for declaring blocks, but the creator of Odin really didn't like that, so he just went with opening and closing brace, right? Whereas I've used so many different styles, like the do end from I think there's some of that begin and end I think is in Ruby. So I had seen plenty of that before, and so it wasn't weird to see that. Once I started seeing it all the time in Ruby, it wasn't weird to see it anywhere else. But in Elixir, which I've been using for a long time, it's def do end for a function, but declaring a block, like same thing with if statements, so on and so forth. I guess in Elixir I've never tried just doing like a, scoping a block of code this way without any sort of predicate or whatever. So anyway. James has been around. Yeah, I've been... I'm very promiscuous with language use. Not even because I chose to be that way specifically. That's just how it worked out for me. I've had to use so many different things. If I could use just one or two languages for everything, I would. Odin has turned out to be something that I think I could use for most stuff. But if I needed to do a web app of any kind, I would probably just stick to Elixir these days.
I'm gonna go ahead and stick with that because I think that's the way I've typically prepared to do it. I don't know, let's look it up. Let's look it up. Let's see what's a good term. I mean, it's never too late, but you can see having or relating to two sides or affecting both sides, right? It's kind of that nice sort of feel for -1 to 1, right? And unilateral, right? Only one side, right? So I don't know. I'm gonna leave it that way because that's the way I typically name them. So let's just do that. But you can imagine other names, and you can pick which. When you're doing your version of this code, you should pick whatever makes the most sense to you, right? Certainly. So that's
It's all the same to me, dude.
random unilateral. But the other thing that we might want to look at, right, is this format seems kind of useful too, right? We sort of have this thing where we're doing, we wanted to produce something. In fact, we did this whole math. We had this whole math situation about it that we did, right? We came in and we said this whole thing here, where we were talking about, we need to solve to produce a number between -1 and 1 or whatever else. What would be nice is if we could just do that from now on without having to worry about doing the math. We could just ask for the random number that we wanted, right? So we could just say random, between. So something like random real between or something like that, or just random between, and say like minimum and maximum, right? Because then we could just do something where we say, what do you actually want this thing to be, right? Now, of course, in this case, it just so happens that the equation that we wanted was between -1 and 1, so we could just call random bilateral here, right? Because that happens to be exactly the range that we wanted. But you can imagine us wanting something a little more flexible than that. And so, let's just throw it in there as well, just so we can kind of have that nicely rounded out, right? So basically, that's just...
So, hold on. Toggling back and forth every couple seconds here now. So, and I thought it was, so it's bilateral. And like if this was, what does that return? Is it going to be a float? I think so. So it'd just be this, I'm pretty sure. And then this would just be that. Is that right? Yeah, that would totally be, this also needs to return a float. So I think that gives us exactly what we would want. But now that he mentioned it, and I was kind of looking at it funny, and I was like, can I just like call, isn't there just, it would be surprising to me if there isn't a call that does just let you provide a number between, or gives you a random number back between two different values, right? It seems strange to me that there wouldn't be something like that, and that's kind of what I was wondering with this choice, like give me a random choice between. Isn't that what he called? Yeah, he called it random between. And it's like giving me some deja vu, actually, because I thought that maybe we had actually used a call that does exactly like that, does something exactly like that. But I think I'm just thinking of lerp, right, where I can, do the A and B and the T. It's like it would be a similar signature, but I don't see anything exactly like that in Odin's rand package here, so we will just do this because it seems like a nice thing to have. Kind of seems like we might want to provide the type as an argument, so that we don't have to be locked into floats. Maybe I want to do something like that. I think, it'd be like this, right? Yeah. And this can just return nothing, I guess. I don't know. Yeah, let's do that. Gives me an excuse to use parametric polymorphism, so why not? And so then I would just say I want a random bilateral that happens to be a float. Yeah, that seems fine, I guess. It feels weird. It feels like a lot of ceremony for something that doesn't need to happen. But this way, right, if I wanted a random, in 32, I could do that as well. I don't know.
Two random bilaterals, like so. So that's all good, but you can imagine taking this even a little bit further. What if I wanted to have a way to make those two, we could do random bilateral, bilateral 2, right, or something like that, and that actually produces this kind of vector for me. Now, we haven't seen much of that yet, and I expect we'll see more of it in the world thing, so it's a little premature to go down that route, so I'm not going to. But you can kind of see where that's headed, right? So let's take a look at this right here. This is another case of that random choice thing. We're choosing bitmaps out of this. So this would just be saying, okay, whatever that array count is, we want to pick one of those, right? That's how we're doing that. Random choice. Actually, so I don't need the parentheses anymore. Random choice. And similarly, this one as well. Random choice at series array count. So now we've got, that kind of nicely cleaned up. And
oh, interesting. Okay. Yeah, I'm doing a little bit more of this than I expected to, but I think it's okay. So we have random choice, and I don't know if it really makes sense to yeah, it kind of makes sense to use parametric polymorphism here too, right? Because we'd have he has to pass in the series, but I don't need to do that. I just need to pass in the count. No, we could just make this a U32. Because if it's just a random number, well, I don't know. But I can see like cleaning up this a little bit, right, does seem useful to me. So we'd basically just do, well, what is this call gonna give back? I think it's just gonna be an int, right? What do you call that? Choice count. So that's gonna be an int. Then, yeah. And we're calling int max here, so. Oh, and I just noticed this too. If we don't want to cast this to an F32, we want to cast it to T. Can we do that? I guess we'll find out. All this compiles in the end. Okay, so this will just be whatever that choice count happens to be. And I think we just return that, right? Yeah. That looks right. Okay. And then so random between would be, we'd have like an A and a B, I think. Can we do something like that? T is not declared. Can I do it after the fact then? Yeah. So you just have to put the type up front when you're defining that. There's something about this which feels, and forgive my turn of phrase here, it just feels a little bit masturbatory. I don't know. I don't know what else to say about it. But I mean, it is cleaning up the code a little bit, just so we understand what's going on with this code. You know, we want a random choice that is as long. We just want to pick one of these elements randomly. And you know what? There probably is a smarter way to do that with the rand package. Now that I'm like implementing this and I'm looking at like if I look at the choice procedure here in Odin's rand package, yeah, it seems like if I give it a slice, it'll just give me a random element. Yeah, that's literally what it says. But I don't have a slice, I have an array. So I wonder if just giving it the address of the array would be good enough. We'll see it. We'll see if that'll actually do what I think it's going to do. But that doesn't mean we wouldn't still want these, I think. It just means we wouldn't have to implement this random choice call. Like we can see, yeah, if we just passed in rand choice, and then the array was the game states. I called this gas. That's a typo. Game state stone or ground technically. Cannot determine polymorphic type. That's right. I think I wanted to try passing that in by address. Nope. What is? Oh, I can't even see what the error is. Great. Here we go. Cannot determine polymorphic type from parameter pointer to yada yada. Okay. How to get a slice from an array then? Because I was pretty sure that I could just get the address of an array and that would be a slice, but I guess not. Maybe if I cast it to a slice. Cannot cast, what is this error now? Cannot cast that as bit, wait, what? Cannot cast a reference to this array as bitmap. Oh, because we want it to be a slice of pointers, is that it? No? It also doesn't like the custom code that I wrote. Oh no, never mind. This is all the same call. It's complaining about the same call in 3 different ways. Oh, you know what? It's probably because, yeah, I'm a dope. I forgot how to cast things in Odin is all. So it's not a pointer of bitmaps, or it's not an array of pointers to bitmaps. It is just the bitmaps themselves, but I needed to wrap this, I'm pretty sure. Okay, now let's see what this error is. Still doesn't like it. Yeah, damn. Maybe if I read the docs instead of just goofing around with the compiler like a nincompoop, maybe we'll get an answer. How about arrays? Fixed arrays. I just want to see, because I can't remember. I feel like I've done this before. I just can't remember the mechanics of how it works. Creates the same arrays above, then creates a slice that references it. I should have read Carl Zielinski's new Odin book. I wonder if I should check the Discord. That might be the most sane thing to do at this point, because I feel like this should not be this much work. Let's see here. Maybe the slice package has what I want. Oh, jeez, man, it's crazy how you don't use something. I didn't even find the answer, but it finally popped into my brain, or at least I'm pretty sure. All I needed to do was this, I'm pretty sure. Right? That gives us a slice to everything. Okay, now, and we don't want it to be a pointer. Okay. Now, is this error more helpful? Must be an integer, and we got a bitmap. Oh. Okay. Yeah, I just wrote this wrong. Okay, please forgive me. That was kind of embarrassing, but this is what happens, you know, when you don't use a programming muscle for a while. It just atrophies into nothing. So we want to take a slice. We don't want to take a slice to this. Oh man, wait, no, that doesn't seem right. This should, because this just takes, yeah. Why does it have to be... Oh, because... Okay, duh. We don't need that. Wow, that would really clean this up. Cannot take the pointer address of all of this. What if I wrap that up in parentheses? Can I take the pointer address of all of this? That's strange. So what I think should be happening here is that a random choice of one of these bitmaps in the game state's stone array, right? Because that's got all of our ground bitmaps. Should give us a bitmap out, and then I want to take a reference to that bitmap, but the compiler's telling me it's not allowed. So yeah, of type bitmap to pointer to bitmap in assignment. So yeah, that seems kind of odd to me. Whatever the result is of this should definitely be a bitmap, and I should be able to just take the pointer of that. Yeah. Oh. Give me a second. I'll get it for you. It's okay. Hold on 1 second. I gotta do a dad thing real quick. All right. Sometimes the youngest sleeps in the office, and so we have a baby monitor in here that moves between this room and our bedroom. But anyway, had to hand that off to my wife. So yeah, I don't know why this won't work. It seems like it should work. Like, do you just want me to... What do you want from me, Odin? Because this is the correct error that I would expect to see, right? Cannot assign, etc., of type bitmap to a pointer to bitmap in assignment. So if I just take a reference to the result of this, why on earth is that? Like, that should be a pointer to a bitmap. Yeah. So it's just strange that this won't work. Maybe the way to do this is to just not make this a pointer, right? And then we can see if this all works the way that I think it will. But it means we have to pass this in by reference, right? Because now we no longer have a pointer. So just a bit weird. Let's see if this even compiles. It does. Now we'll see if it runs. Yep, so that gives us exactly what we wanted. Just really strange. Maybe it's because it is because this procedure is using parametric polymorphism, like the compiler. I wonder if it would compile if I did make it a pointer. I just want to try this out. Even though the language server is complaining, it could be that the language server doesn't know what it's talking about. But you never know. It could be just that the compiler would not allow something like this to happen. Yeah. That makes sense, because we tried compiling it before. I just wanted to see. Double check. But other than that, you know, this right here, right, seems a lot better than this. And it also saves us from having to write that random choice code. So, bit of a tangent. But I looked at that call a couple times, and I was like, you know what, this seems like it should be useful. And it totally is. So I'm just going to go ahead and use that for the grass as well. And then that greatly simplifies that. And then we can do the same thing down here. We still got to use this bilateral stuff. I don't know. Honestly, maybe there is a way with the RAND package. But if there is, I can always, you know, come back around and add that in later. So we got to do the same thing here for the tufts, right? So I'm just going to go ahead and drop that in here. And this doesn't really matter because this is just the results of whatever this is, but we still have to change that to pass byte reference, and we want this to be on the tuft array, not the stone. So that actually looks pretty nice. We get to save implementing a call and just really improve the way that code looks. So I'm happy about it. It's a little bit of a struggle. Forgot how to get a slice out of an array, but there you go. We're in good shape now.
Yeah, that looks pretty good to me. That looks pretty good. So let's go ahead and implement that. Let's make sure this compiles okay. Oh, right, we didn't actually make our seed function yet. So here's our seed function. There we go. Random series. And this is our seed. And our seed takes some kind of an unsigned integer there and returns the result. Oops. So in order to do our seed function, right, this is going to be really simple. The seed function is probably the easiest thing. All we really need to do for that is assign the random number index to be whatever the seed value that comes in, like so. But we also need to make sure that it's sort of, you know, that it's going to be kind of clamped in here, right? So it's going to be, we don't want to be indexing outside the range of the table, right? So we want to do something where we're going to make sure that we mod by whatever the array count is of that random number table, right? So that way it's always inside the table. So yeah, I mean, implementing the rest of this is just pretty rote. It's basically what we've already done. So I'm going to write all these in terms of essentially, you can see this operation happened in each one of them, this random number table, you know, you increment the thing and go. So what I'm going to do is just say, all right, let's assume that there's a thing which is like next random uint32 kind of a thing, where you pass the random series, and that's responsible for getting that next random number. So it just returns you that random number table with the random number index, and I can just make that index now, right? We don't really need to be verbatim because it's inside the series. So that series index, we're just going to go ahead and grab whatever one is out of there, and that's going to be the result. And then we're just going to quickly test to see if we have outstayed our welcome, right? So the series index, if the series index is now greater than or equal to that size of the table, random number table, we'll go ahead and wrap it back around to 0, right? And then we'll return whatever it was, the result that popped back out.
So basically, when we call int max in here, it's doing the same thing, but it's all underneath the hood. So he's just doing, you know, he's showing how to do that bookkeeping that we just, you know, don't have to do. You could do it yourself with Odin, but I don't feel like it. I don't think it's necessary because I'd rather use the standard library stuff just because that's what people are going to be familiar with in the unlikely event that anybody's ever going to look at this code besides me. But it's even helpful to me to not write my own custom code if I don't have to. If I write custom code, it should be to solve a problem that I have specifically that can't be solved using code that already exists. Not that I shouldn't understand what's going on, right? Because that's the whole point of Handmade Hero, is trying to have a deeper level of understanding. But path of least resistance and path of most sanity, actually, is the way I would try and think about it.
Once we have that, really all we need to do is produce, you know, use that to produce all the other things that we actually needed, right? So in this case, we've got, you know, we're going to ask for the next random number that comes back, and then we're going to mod it by whatever that choice count is, right? Like so. And that's really the entirety of the function. Similarly, same thing here. Like all I'm really doing is just, you know, literally doing the rote transformation of saying, you know, next random uint32 replaces wherever we were going to look up in the table, and that's how we produce the result now, right? So there's that result. We could also make this be something that's pre-computed, right? We could say something like, you know, divisor or something like this. And we could say, let's just allow the compiler a really clear way to pre-invert that number, and then we'll multiply by it instead. And that's just allowing the compiler to know that we're just doing a coefficient multiplication here. Now, is that really all that important? Not really in this context, but you know, usually CPUs are much better at multiplying than they are at dividing, and phrasing things in terms of multiplication when you can is typically a good idea.
I don't know if this is necessary whatsoever because this is 10 years in the future. And I'm sure a lot of changes have been made in terms of like, well, I shouldn't even speak out of turn because I really don't know, but I assume things have changed enough to where maybe doing this explicitly up front is not necessary, but I'm going to do it anyway just for posterity's sake, I guess. It can't hurt much, I would hope. So we just do that. I guess it doesn't need to be a float, especially in case t is not, well, maybe the result of this should just be cast to t so that we don't have any weird issues when we go to divide it, or multiply it, rather. So I think just doing the same thing down here is all we should need to do.
So since it's literally like trivial for me to modify the code to do that, conveniently, might as well, right? So yeah, let's go ahead in here and just, again, not particularly doing anything special here. I'm not even trying to make these at all optimal or even interesting. I'm going to say that if we want to do random bilateral, we've got that code here the way we did it before, right? It's this sort of 2 times whatever the unilateral result was, right? So here's random unilateral, and then you subtract 1. That was how we were doing it. Really straightforward.
Oh, that does seem a lot smarter, doesn't it? Yeah, so we don't even need the divisor, right? We just do, like you said, multiply this times the result of random unilateral. We'll just pass t in there to get the exact type that we want back. We don't need to do this. We subtract 1, and that seems pretty straightforward. Now this should be outside. And now I think we're good. Go ahead and rebuild and rerun. Ruh-roh. Something went wrong. Everything got splatted in the same spot right there. So what did I screw up here? We have our max random number, 1 divided by that. We get the divisor out, multiply it by whatever the result of that is, and then we do 2 times the result of that minus 1. Maybe he messed something up. I should wait to see if his actually works.
And finally, if we did want to implement this random between, we worked out the math for that. You remember how we did it? We basically said, okay, there was sort of a range, and that's the max minus the min, right? That's the total range of values. And then what we want to do is say, all right, to produce the result, we take a random unilateral from the series. Oops, got to add that series in there. We take a random unilateral from the series, and we need to multiply that, the range times that. So that gives us somewhere in the range, and then we just add that min offset to it, right? That's a pretty straightforward way to produce something in between those two. We know that if the random unilateral produces 0, then we'll end up, I could phrase it this way to make it a little clearer. So you start at the minimum, and then you're just taking some amount of the range and adding it in there. And again, this is that function format that I talk about all the time, the blending function. Start somewhere and you go a certain amount towards the other end. And we could phrase it in that way as well. In fact, you know what? Why don't I do that just to reinforce it here, just to make it clear what's going on. I think, did we make one of these? Did we make a linear blend function? We didn't. Oh man, how disappointing is that? I thought we probably would have already, but it looks like we never did. That's too bad. That's too bad. And I feel like we've been using it, right? I mean, we used in the sim region. I feel like we definitely, well, actually, you know what? I think we may have moved it out to
yeah, this is feeling pretty lerpy, right? Is that not exactly what we just did?
To the entities, right? The get stairground. Yeah, so I mean, you can see that this form pops up everywhere, right? It's the same thing, right? You can see it happening. See how it happens here and here, right? When you have the range and the minimum, and then you multiply by whatever the amount from 0 to 1 is that you want to go. Well, sigh. That's just the way that goes. But what I was basically saying is we could have done it this way, which is like a linear interpolate or something like that, which is often called lerp, right? You can say I want to go from the min to the max by some value, which is going to be random unilateral series, right?
Yeah, totally. So we'll just get linalg out of here. You definitely did it before. I just don't know, where his definition is, because we've always used the linalg. What is it, lerp? Yeah, it's just straight up lerp. And we're going to go from min. I guess I should change these to be min and max. Go from the min to the max. And then this is the t, right? Make sure I got that right. I know I passed those in the wrong order before, and it caused me some headache, but I think that's right.
So that's, sort of the thing that I assumed that we had already written. Doesn't look like we did. But again, that's just that blend format I've talked about on the stream multiple times. It's like, it's like an A and a B that you're going between. And it has that form of of 1 minus t times A plus t times B, right? And at the risk of beating a dead horse, because maybe people didn't watch the old streams or something like that, this again is that sort of, it's so important that it's worth saying over and over and over and over again until we're blue in the face, just so there's no chance that you could ever possibly watch Handmade Hero and not know it, It's 82, right? Yeah. Just in case. Again, the reason that I say those two are the same equation is because if you're going to blend from A, between two things from A to B by some value that goes from 0 to 1, which is t, right? That is that sort of universal blending equation, which is 1 minus ta plus tb, right? And if you multiply that out, you get 1 minus ta, right? I'm just distributive property, right? Straight up high school math at best, tb, and so if you think about what happens here in terms of grouping these terms, you can see that there's a t in both of these. So if we go ahead and group that out, like this is the equation grouped by a, right? This term here being grouped by a, so it's 1 minus ta. If we instead grouped it by t, right, you end up with plus t, b minus a, right? That's just pulling out the t, and you end up with a negative a and a positive b, so b minus a, right? That is the range. That's the difference between a and b, and this is the min, right? It's the place you're starting at. Now, they don't have to be mins and maxes. It doesn't matter what direction this goes. You don't really care. So min and max is irrelevant. It's really just a and b, but in terms of the phrasing that we were using before, it's min and max, right? So you can see that these are the same equation. They're just grouped a little bit differently. And yeah, like I said, you can never really repeat this too many times, because if you don't know this equation by heart cold, you are going to be a sad panda, because it is basically the most useful thing you can possibly know. If you could only know one thing mathematically in game programming, it'd be this. Hopefully you know a lot more than one, but this would be it.
So my brain is definitely breaking. The compiler is telling me that I'm not using the linalg package after importing it, but we're using it right here to call lerp. So I'm really not sure what on earth is going on. That is a pretty messed up error to get, right? Because now if I do this, wow. How can I be using that call here if I'm not importing it? This is just unprecedented. I don't get it. Why is this happening? Is it because I'm importing it elsewhere? Like, that doesn't make sense to me. Yeah. There's just something very strange afoot here, other than the fact that we have this new bug now that I can't make sense of.
So anyway, there it is, and since I bothered to write it, I'm gonna stick it in here and use it, because, gosh darn it, the world is running out of code, and we need to conserve the code. It's a scalar operation, after all. It should go in scalar operations. There it is. No, it's there. There it is. See? I knew we had it. How come I couldn't find it? Is my search busted? What did I do? I fat-fingered it, didn't I? Lame. All right, so there it is, and you can see that I've already written it there, so that's good, so we can do it. All right, okay, I feel better. I was like so ready for it to be there. I was like hoping it was there, and then I was like, it wasn't there. It was this big letdown. So okay, so it's just a search, fat-fingered, and so, disaster.
I'd rather have the problem that he just had where he had to write it twice than whatever this problem is that I'm seeing now, where I'm able to use a package that I have not imported in this file. That does not seem right at all to me.
Disaster narrowly averted. Disaster narrowly averted. Good, good. But yes, again, if anyone who hasn't gotten that, totally down. We'll still say it a few more times probably on the stream, but that's the function that you gotta know. So there we go. That's a lerp going on there, and that's all good. So let's finish the fixer, the replacement here. So we need to change this to a random choice as well, and just grab out that bit there. These are random bilaterals, so we can do, oops, that's an address of series. There we go. Another random bilateral, and let's see if that worked out for us. It did. That's what we expect to see, so that's all good. And what we could do too.
Well, damn. He does not have the bug that I have, and I'm looking at this math, and I can't figure out why that is. Let me go back here and see. It's not a good feeling. Not a good feeling at all. So we have random unilateral here. It takes 1 divided by the max random number, or max random value, to get a divisor. And then it multiplies that out by a random value. Yeah? Seems good. And then random bilateral does the same thing, but it multiplies by 2 and then subtracts 1. So, like, there shouldn't be a difference. If we just go back to the way things were here, right? Does that just fix our whole problem? It does. Oh, it's because, yeah, it's just zeroing out. So this does need to be explicitly, okay, once I actually use my brain for a second. It's just kind of weird because of the parametric polymorphism. That cast is going to do weird things if we're doing anything besides getting a float. And I mean, when I think about it like that, in fact, this is still, it's still busted. What's that about? Oh, because I divided it out. Okay, now this should work, please. Okay, yeah, now we're good. Yeah, looking at it now, it doesn't make sense to have these be anything other than a float, but I still would like to be able to do it with any type of float, you know, so it kind of makes sense. Maybe there's a way to specify that whatever this type ID is, whether it's an F32 or F16 or F64 or whatever, it always has to be some kind of floating point value, right? But I think I'm happy with that.
Busted. What did I do? I fat fingered it, didn't I? Lame. All right, so there it is, and you can see that I've already written it there, so that's good, so we can do it. All right, okay, I feel better. I was like so ready for it to be there. I was like hoping it was there, and then I was like, it wasn't there. And it was this big letdown. So okay, so it was just a search, fat fingered, so you know, disaster narrowly averted. Disaster narrowly averted. Good, good. But yes, again, if anyone who hasn't gotten that, totally down. We'll still say it a few more times probably on the stream, but that's the function that you got to know. So there we go. That's a lerp going on there, and that's all good. So let's finish the fixer, the replacement here. So we need to change this to a random choice as well, and just grab out that bit there. These are random bilaterals, so we can do, oops, that's an address of series. There we go. Another random bilateral, and let's see if that worked out. For us, it did. That's what we expect to see, so that's all good. And you know what we could do too, I don't know if we actually really want to, but we could make it so just to demonstrate what happens there, we could make it so that this seed kind of permutes itself periodically.
I don't know if I ever even made sure I was at the right zoom level. Whoops. I was not. That's okay. No big deal.
I don't know if we really care about that, but that's something we could do so we could see how it changes what the background is, but we'll leave that for some other time. So anyway, what we can do is we can continue this down now to anywhere we were using the random number table, right? And so we can make another random series here that's something else, 4, 5, 6, 7 or whatever. I don't know. It doesn't have to be something else. It could be the same series. Who cares? We'll deal with that a little bit later. But point being, what we can do now is make sure everything works off of this, because why not? We spent the time to do it. We might as well clean up all the code. And so what we can do is just say, all right, get rid of that. It looks like we actually have a random choice variable here, so perhaps I shouldn't have called the function random choice. But it's an oversight. Let's go ahead and say that random choice is going to be, what is this actually a choice of? This is actually like a door direction, right? I think is what we actually did. So let's call that door direction, because that's actually what it is. It's not just a...
Okay. Do I have that same thing? Yeah. So anywhere we have a random choice, not that, because I don't have that procedure. I got rid of it. But even so, I think door direction is a more useful name. So random choice becomes door direction, and then yeah, actually we don't, I guess I can set this to max random value. Doesn't really matter, but yeah, and then here, I don't think there's anything one-to-one really. Like you do the random choice call and just pass it like a list between 1 and the number of choices, but that's a whole lot more work for like no gain. So I don't see the point in doing that.
A random choice. It's the random choice of door direction. So it looks like we want to do random choice series of 2 here, and we want to do random choice series of 3 here, like so. Otherwise known as, if that's true, then we do a 2, otherwise we do a 3, right? Is that basically all that was doing? Seems like that was true. So let's go ahead and make that be true. That was easy.
That is so much better, actually. So, oh yeah. Yeah, that was funky the way I did that. Or maybe that's just, it looks funky to me now that I've seen him clean it up and his actually looked the same. It had to be a little bit different just because we weren't doing, that static table of numbers that he used. But essentially all this is, I don't know if I'm assuming we're not using random number anywhere else, but maybe we are. No, we aren't. Okay. So this is just that. And there's nothing else to it, right? Oh, this has to be greater than 0. Yeah, because we can't treat integers as truthy or falsy values. Okay.
And then we come down here, and it looks like there's really not much else in terms of randomness. Looks like just the familiar set, where the familiars were going in our random familiar generator here. But we can do that one as well, right? We can just say that we want, I guess it looks like it's just an x, y there. And it's an x, y between -7 and 3. Right? I mean, that's what we wrote here, because we're producing a number between 0 and 9, and then we're subtracting 7 from it. So it's between -7 and 2. Yeah, so that's kind of hard to read, and we don't even know what's going on there. So I think this might be another good reason to augment this with, one of these random betweens that works for integers too. If we did something like this, where we could say, give me a min and a max in integer space and get one out there, that seems like a pretty good idea to me. I don't know about you guys. So yeah, I would say in this case we could use that form. We can't use the lerp because that's floating point, and you wouldn't want to produce those intermediate values. You need actual integer values. But we can still do the exact same thing, right? It's just the min plus the max minus the min as the range. So all we really need to do is just say next random uint32 mod that range, right? Like so. And so that way that'll give us, it'll start at the minimum, and then we'll get a random number and we'll produce some offset, basically doing the exact same thing we're doing here, only at least now it'll be a little more readable. So we can say, random between past that series, and then say, all right, we want a random number between -7 and 2. And now at least we can see that that's what it's doing, right?
That does seem a lot better. Yeah, so if I just did, and the nice thing about this too is that if I go into this call here, yeah, so I just need to pass in the type, which it looks like we want an int32. Did I not highlight both of those? And then here, we pass in those values. And I didn't have to do this twice. I didn't have to write a procedure group because we can just use the parametric polymorphism, right? And that's better than doing a procedure group as well, because either way I'm going to have to, like, if I used a procedure group, we would have to, well, I mean, if we pass them in like this by value, then I don't think we need to do the cast. But if I was going to use a variable here, say, right, like that, these numbers I think might be defined somewhere as constants, but maybe not. I know they are for like the size of the rooms. I have constants for those, but I don't think I have them for these, because these numbers are specific to keep the familiars from spawning outside of the room, I'm pretty sure. Whoa. Now the language server is telling me I don't have that package. Super strange. Okay. Oh, and it's telling me I can't cast this as I32. Ah. Wow. And that's because we're doing the random between, which calls the random unilateral. That's super interesting. Huh. All because, wow. All because we decided to use this procedure with an I32. So that does make a case against using parametric polymorphism. I just feel super dumb writing this code out. I gotta be honest. Like, I feel like there's certainly a better, more obvious way, but especially after hitting this, I wasn't sure about it. I thought, this should work fine. But yeah, then needing to use these procedure calls to get an I32 immediately kind of screws all this up. kind of makes sense just to do away with the whole divisor thing, even though I spent all that time worrying about it, and just do this, right? And then hope that, you know, whatever optimization needs to be done with that is done properly, and that it's treated just as a multiply instead of a divide. Probably doesn't matter that much, but now I'm looking at it and I'm like, this seems bad. Maybe it should have been a procedure group, and then we just write out, you know, each one that we need as we need it. Yeah, and it looks like this is still, it's still not happy with it. So, oh man, what a crying shame. This just did not go at all the way I would have liked. But whatever, you win some, you lose some. So we go back down to that random between call. I guess I could always say to hell with it. We're going to cast the result back out to an int, but that feels pretty nasty, you know? I wish I knew, because I think there's like a way to like specify that this should only get floats or ints the same way you can for slices, but maybe that only does work. Maybe you can only do that for slices. I don't know. This is like a good learning opportunity with respect to Odin, but I kind of want to just get through the code, right, and worry about cleaning that up later. So what was that value supposed to be? That was a 10. So if we make this, if we make these floats, and then we cast them to I32s, this is so nasty, but I don't want to spend any more time on this code, especially because I didn't think it would take me this much time. But I think that'll work now. And of course, the familiar is stuck in the tree here, so that's too bad. But oh wait, this was supposed to be, is that right? 10 and 3. Let's see.
And similarly, here I want you know, that random number between negative 3.
Oh, negative
right?
3.
And plus 9, so it's going to be 6, I guess. Again, I don't really know what we were doing there, but I guess we were just trying to figure out reasonable places where the familiars could be. But yeah, but I don't know. So we'll just do that and make sure it works okay. That doesn't look quite right. Our familiar is gone. Where did our familiar go? Random between series, pass them in, get the max min, we mod by that, we add. Of course, this is coming out as a uint32, which is, you know, is not the best possible thing. So I wonder if we want to make sure we can sort of do that to make sure that we've got the positive negative range there. But yeah, what did I must something up. Let's go in and set a breakpoint there. There we go.
This seems like too big a range to me. -3 and 6.
Wait, so no, it's offset from the camera tile, so that's fine. All right, so let's double check here. Random between. Let's see, min and max. We actually want to see those in regular numbers. So max minus min is 9, which is what we expect. So what's our result there? It's -7. That seems like a totally plausible value to me. And what happens here? Result is 5, which is also a totally plausible value. Yeah. So where did our familiar go? Our familiar is up there. So I must have really misread what we were doing.
Yeah, I was confused about that too. If I go back and look at this code before we did all of this, so it's mod 10 -7 and then mod 10 -3. Mod 10 -7. So that would that mean 7 tiles to the right or the left? I think it's, yeah. Man, it's been so long since this was written that I don't understand the consequence of the math here. Mod 10 minus 7. Yeah, that would give you a value +3 or -3 in the X. And then this would give you... Well, no, that doesn't seem right either. Because if it was +7 in the Y, that would be way too far off as well. I don't know. I really don't know.
Which again is why I said I wanted to replace those routines. I guess I was not concentrating well enough on that. So I thought that it was saying -7, so it should start at -7, and then it should go between 0 and 10, right? I don't see what the... Yeah, I don't know. I feel like that. Yeah, but I must have misread that there. I guess what I can do is just...
Were these both mod 10? They were. Yeah. Okay, yeah. Between 10 -7, yeah. But that doesn't... I feel like it's -3 and +3. You don't want it to go... Yeah, I think that's right. I mean, it doesn't matter for us because for whatever reason, the familiar is just spawning like right in the middle there. I guess we could change the seed and see. I'm just not seeing the problem that he was seeing. It's, what is it? It's reset. Put this back to 2048. Why not? Whoops. And then maybe we'll get the familiar. Yeah, so now the familiar is down there, which I kind of like that spot better. Spawning so close to the player, it seems like it would be too easy for me to get stuck inside the familiar's hitbox. But I think this is right, because this is saying, and this doesn't seem right either, because this is saying, give me a Y position, a Y tile position that is 3 below the origin or 3 above, and this would be, you know, 7 to the left or 7 to the right. If so, I think the way to think about this is if I changed this to 0, then the familiar should always be in the top right. Yeah. And that's just to the right, so not quite right, but that's, I think, all that's happening. I think I was overcomplicating it, just looking at Casey's code and trying to make sense of where he was getting those numbers from. But it's literally just like how many tiles to the left or the right or up and down do you want to go from the origin, right? Which is at 0, 0, 0. And that's all that does. So I think we want, yeah, -3 to 3 sounds good. And then I think like -5, because how many tiles wide are we? Tiles per width. It's 17. So negative, like half of that would be 8, right? Or just above. So it could be -5 to 5 or -4 to 4. Yeah, I'm fine with this. We get it.
Take a look at what it actually was. Let's take a look. So what did I misinterpret here? We're modding by 10. So whatever comes out of the random number table is going to be between 0 and 9, right? Well, you know what? We don't even have to guess. I guess we'll just go ahead and see what that is. Next random uint32. You know what it could be? It could be that it was just happening to produce a number that happened to be pretty far forward, and we just haven't ever rerun it again. Because, you know, it was always going to produce the same random series since we were going through the table in the same order. That could actually be the whole thing. Could be that I translated it entirely properly, which does seem potentially to be the case. But let's take a look. Let me just verify that that's the case. We're offset 1, 6. So let's see what we get there. Oh, okay. So yeah, we're totally fine. So I think what actually was happening there was we just happened to have a fortuitous random number, and one time in one, you know, when we were kind of going through things.
Yeah, the way it was originally written, the familiar easily could have been off or, you know, up, too far up or too far down off of the room. But yeah, that original code was just wrong, and we were getting good results. Okay.
It turned out that it was, you know, some sort of a situation that fortuitously still placed it in the right spot on the screen. I feel like that's probably true, but, you know, I could be wrong about that. So yeah.
Okay, I hate to have to do this. I've never had to do this on the stream, but unfortunately, I have to go use the bathroom and relieve myself. So I'll be right back. All right, sorry about that.
Yeah, let's think about this for 1 second though. If the mon starts at -3 plus 2, yeah. So if I go back in here and just sort of put this back in, if I actually wanted to do what's probably the right thing for the familiar randomness wise, we probably want his y offset. If the mon star is at camera tile plus 2, we probably want the familiar to be at like something that's going to be negative off the camera tile, and then it's probably fine however far he is in either direction, -7 to 7, or something like that. I don't know. Let's take a look. Let's see what that gives us. So that's fine, and let's generate just a few more of those just to see. Yeah. So that looks a little bit better in terms of what's going on with the familiars there. Similarly, maybe give them a little more range in terms of the locations there. So that looks pretty good. Yeah.
Yeah. Now this all makes sense to me. I was like, how come we were getting anything that looked correct before? But I remember when we were spawning a bunch of them, like let's say 15 of them, we were getting some pretty crazy placements outside of the room that we generate. Yeah, so there we go. That seems better. Yeah, in this range, if we're what was it, 17? I just looked at this number and I already forgot. If we're 17 tiles across, we could have it go -8 to 8. Yeah. For some reason, I was having the number twice. That's where I was getting that -4 number from. But if we've got 8 tiles to the left and the right, and then 1 tile that we're, where the camera is, where the center of the screen is. We have 7 tiles on either side, and so yeah, that makes. Well, we have we have 8 tiles on either side of us, but the trees make up the far end, so we want to be inside of the trees where we're spawning. Okay. These numbers now make total sense to me. Before I was like, what the hell is going on? And you can see now we've got our familiar spawning in basically the same places where Casey's are, so good to go.
And I feel like maybe we've got to do, I realize the phrasing of this routine is a little bit off. So like, just hear me out for a second on this. So basically, we've got this situation where we're saying min and max, and in this case, we're including the max in the range. And in this case, we're not including the max in the range. I mean, it's pretty self-explanatory, right? If this came out to be 0, it would be kind of invalid, right? But if it comes out to be 1, then we're only ever going to produce a 0 here, which means we always produce the min. Whereas what we want to do, if there's a range of 1, is produce either the min or the max, right? And so on and so forth. So I feel like really what we'd want to do to match this routine is include that extra, the max. In fact, you could say it's the max plus 1 minus the min, right? Because we want to be 1 over from that. Hopefully that makes some sense. And that's why we were seeing that familiar with only on one line before, where it really should be on 3 lines, right? And so now it is on 3 lines, and that's better.
So that's a good point.
I think that's a good thing. So yeah, now we got that randomness in there. That's pretty good. I think that's a nice thing. So I'm not sure what to tackle exactly next. We've got about 15 minutes to go, so we probably should do something else relatively substantial, not too big, but we've taken care of everything regarding the random number table here. We could, I suppose, also do something where we like, move this down. Let's make sure that nobody's asking for that outside here. Yeah, they're not. So I think we're pretty much good. We've removed any dependency directly on that table from the code, and so that way when we vaporize it, we just redo these routines. And in fact, basically, we set ourselves up so we only have to redo one routine, which is next random uint32. That's the only thing that we'll really have to redo. Well, and seed, I suppose, when we switch to an actual random number generator instead of a table. So I think that's in good shape. Yeah, so what next is the question. And I don't really know which one we should do next. I suppose what we could do is we could try doing, let's try doing a pre-composite. Why not? I mean, it's the smallest thing to do. We could probably do that right here. So what I'm thinking, right, is, I want to take this draw test ground thing, and I just kind of want to make this into something that can do a composite of the ground without having to redo it every frame, right? So what I want to do is say, oh, I want to, build test ground or something like that, right? And make that happen. And I guess, technically I could still call that draw test ground. It's not really a big deal. But basically what I'm going to do is take this game off-screen buffer thing. I want to make that so that I can just sort of pass something that's not actually the real game off-screen buffer, right? So here's what that was, and what I could do is just say, all right, well, loaded bitmap, right? I don't know if you remember. Where's loaded bitmap? Loaded bitmap looks exactly like that. So if you take a look at the Handmade platform, and I've got game off-screen buffer, right? And then I've got loaded bitmap, they're really, really similar. You know what I'm saying? So I'm wondering is, what if we just condense those two things down to one thing? You see what I'm saying there? Hopefully that makes some sense. So that really we don't have two different things, we just have one, and we go from there. So let's say we have a loaded bitmap, and we were to introduce the pitch to that, right? And maybe loaded bitmap isn't the greatest term. Maybe just bitmap would be a better term for it, right? Or something like that. But either way, so let's say I introduce pitch to that. How hard would that be for us to support? Because we only have one function really that uses it. And so if we take a look through here, we can kind of see that really we don't have to care to, we don't really do much that has to deal with that pitch. All we were really doing before was sort of banking on the fact that we could just use the width. But if we were to update things to work with the pitch, you can see us doing it right here with the game buffer. So we should be able to do the exact same thing with our source buffer, right? So let's just go ahead and make that modification, right? Let's say that we go ahead and pull stuff out of the source the same way we do for the pitch, right? And it looks like what we're doing here is we're actually pre-inverting that. And because remember, our bitmaps were like bottom up instead of top down, we were kind of doing a flip in there. But that's kind of interesting because that means we could just bake that right into the pitch, right? So from now on, we could just say it's whatever the bitmap pitch is. That's what we're going to use as the offset. And then that way we set it to flipped or we don't set it to flipped. It doesn't matter which one it is. So whichever way we loaded it in, we could still, the blit would now work, would do the right thing by reading that pitch out, right?
I am very nervous to modify any of this code because I know it doesn't work the same way as Casey's does to begin with. But we'll just go for it and see what kind of disaster this creates for myself. So we're just gonna do the same thing here. We didn't care about the sign before because I was just reading it in, so that it would be top to bottom anyways. But I think this is basically already the same thing because we're doing a little bit of array programming stuff here to make it even easier to deal with. So I don't know, maybe we won't have to change much else anyway.
And so, if I basically turn this equation, this destro thing,
yeah, he turns this into a pointer to a U8. Or sorry, this up here, where was that? Where was source row? And then once he gets to the pixel, he converts that to a U32 so that he can do all this stuff on it. But I made it an array of U8s to be able to use array programming on it. So this could be pretty hairy, but we'll see where it goes.
I basically do the destro thing exactly the same way for the source row. And it's weird that we have two of these here. Weird that we do a plus equals a minus. I mean, this is what we're doing, right? So let's do that whole thing together. And in fact, I guess our source row is actually supposed to be uint dates here, right? Because we're just like destro. So if we do our source row that way, we say, all right, we've got the bitmap pixels. We want to add the pitch you know, with the height -1. And I guess we don't really need to do that part either, because we could bake that into the pixels pointer as well. So that may be what we want to do there too. So maybe we get rid of that as well, right? Let me just put that up there for now, temporarily. So really all we need to do is this, right? We just need to say, all right, we need to move by our source offset y. We need to move by that in the pitch space, right? And we need to move by that source offset x. So this is just pre-stepping us to where we need to grab out of this bitmap, right? I guess bytes per pixel.
Okay, so source offset y, yeah, that's still in there, but we're gonna do the pitch instead. Yeah, this could be pretty nasty. I can almost guarantee that I'm gonna get a bad result trying to do this, and I don't even know that I necessarily need to do what he's doing, but whatever. If it creates a nasty bug, I'll have plenty of time over the holidays to figure out how to fix it.
Interestingly, is not specified in our bitmap. We kind of know that it's always 4. So I don't know that I really want to introduce that into this specifically. So I might just say that there's a bytes per pixel equals 4 on here for now, because we're not really going to allow multiple bytes per pixel in our bitmaps. They always have to be 4. So I'm just going to say it's got to be 4. So basically, it's that. So you can see this is the exact same pre-stepping basically that we're doing. Nothing particularly fancy there. All right, so if I were to do that, right, and now I compile it, we compile, but of course we totally wouldn't work because our loaded bitmap call doesn't act.
And it looks like you just took that value here and multiplied it out by the offset x, right? Just want to make sure I'm capturing all this. This code, I had this code looking so good the last time I touched it, but now, whoops. Sadly, I think I'm gonna. There's just something that's not gonna quite line up, because by the time we get into here, I mean, conceivably we're doing the same operations to get the colors into all of the, you know, places where they need to be, but it's different enough that making the same changes Casey's making, I don't think are gonna work out for me.
But of course we totally wouldn't work because our loaded bitmap call doesn't actually set any of that up at all, right? So what we want to do here is at the end, we want to set this stuff up. So we've got a pitch, we need to set it, and then we need to set the pixels pointer properly, right? And the pixels pointer I'm going to set to avoid now, so to make sure that we don't do any funny business there with it, right? So, all right, so the pitch is always just going to be the width multiplied by the bytes per pixel. And you know, we could actually put the bytes per pixel in here, but I really just don't want to do that. So I guess what we might want to do is just have a global define for that, like something like loaded bitmap bytes per pixel, something like that. You know what I'm saying? And so that we just kind of go ahead and grab that anytime we need it, because I just don't.
Yeah, it seems kind of strange to me that we needed that at all, because shouldn't it be on the buffer? Maybe he took it off of his type, and that's why I have that there. Okay, let's go to the type, and we'll just say bitmap bytes per pixel is 4. In fact, I'll just say this is what bytes per pixel in general is always going to be, because I've never seen it be anything other than that. Yeah, and we're using it right here too, so I don't know what this gives us. I must have kept it on the type and he got rid of it, but maybe not. I don't know. I don't have that code right in front of me. Okay, so there's that, and then yeah, I mean, what's the point? What is the point? Where was that? Pitch. Dang it. Load BMP down at the bottom of this call. I thought we started adding that in. There we go. So it's setting the pitch here is going to be that right there. Okay.
I don't think that that's a useful thing to parameterize in the bitmap. I'd rather have the compiler be able to see that it's just a constant value that doesn't have to worry about. I feel like we did source row needs to be changed based on clipping. I feel like that's a stale to do. Anyway, so yeah, so we go ahead and do that. Let's go down here. So the pitch.
Where was that to do? Did I already get rid of that? That's is that in the draw code? It sure looks like it. I see. He just assigns a new. I don't understand why he's doing some of the things he's doing, to be honest with you. But it doesn't look like we have that to do, so I think we're good.
I feel like we did source row. So yeah, so we go ahead and do that. Let's go down here. So the pitch is right there. There it is. And what is result is not a pointer, so there's that. So yeah, so it's just the width times however many bytes per pixel they are. That's the pitch. But like I said, we want to go backwards, so we're going to make that negative. And then we want our pixels pointer to actually be synthetically set to that top row, just like we were doing before. So that's again just this, where we have that pitch. We want to take what our old pixel pointer was that we were using before, and we want to back that up so that it's basically at that first row. So I think that's the stuff that we would.
So he just did the work of reversing things, but I've already done that, right? Yeah. By changing the index here, I just kind of did it up front when reading the pixels out of the bitmap that gets loaded when it's red, right? And so I don't think I need to do anything with the pixels member down underneath here.
We need to do for that. Let's take a look. Of course, we will crash immediately because I typed something wrong. Hold on a second.
Well, I guess we'll see. There's no way that this works. Yep. So like I thought, I mean, it's kind of cool to look at, but it's clearly wrong. That's fun. I have not seen that particular bug before. That's dang, that is nasty. Okay, well, let's see.
Let's take a look. So let's see. We got the pitch correct. It's negative 1024 there. We are properly. This is not okay. So we've got. First of all, hold on a second. We've got one more thing we need to adjust there. Is now that we've changed our pointer size, right? We would like to be able to. We need to be able to step our stuff. Oh wait, no, and that's not true. These are casted to uint32s, so these are still stepping a full pixel at a time. So that's totally fine. That's not a problem at all. So that's all good. Nothing weird going on there. And yeah, okay. All right, so that's fine. So let's go ahead and step through and see what the whatever it was that I introduced that was incorrect. So, oh, yeah, it's this right here. So the pitch being negative moves us back a row, but we needed to move forward rows because this is actually going the other direction, right? So that's actually stepping us back based on the direction that the pitch is going now. So that was dumb. All right, so that was our only problem. So we're in good shape now. And so now, really, like you can see, what I've done here is just made it so that it doesn't actually matter for draw bitmap. What's actually getting passed to it could be an off-screen buffer, or it could be another bitmap. So I could do loaded bitmap buffer now, right?
Okay. We do need to make this change to be able to go in the direction he's taking things. So it just kind of is what it is. Let me go ahead and... Well, I shouldn't update that yet. Like I can see... Yeah, because we want to store that ground texture that we draw the first time so that we're not recreating it every single time. So it just this kind of needs to happen, whether I like it or not. I just need to figure out what I did wrong indexing into the source pixels here. And to be honest, I don't know if I'm going to be able to figure this out today. But we'll see. So we have our source row. And he doesn't make an offset thing here, an offset variable, but I did it just for readability. So yeah, it's indexing into the pixels at whatever this offset is. The source offset y times the bitmap's pitch plus the bytes per pixel times the source offset x. That seems fine. I guess the main problem is that he casts this to a U8. And then when he gets the pixel out, where is that? Honestly, I actually don't see why this shouldn't work. I don't know why I'm getting that really jacked up result. Because everything should be in the right order. All we did was change the way we get this offset Oh, man. Yeah, we go up by the pitch of the bitmap before it was the width. I see. So because... Yeah, I don't know. I guess I'll just see if this works if I cast this to a U8 now, because that's the only difference that I can see. So if we cast it to a slice of U8s, let's see. And of course it doesn't want me to do that. Probably because I need to take the address of it or get the raw data out of it, probably. And I need to take the raw data of the pointer, don't I? What the hell, man? Oh. Okay, hold on. Maybe we get that out at this offset and then index into that slice. I think that's basically it. Raw data expects a string, slice, dynamic array. Okay, so cannot... Oh, is it because it wants me to transmute? I think that's pretty much it. Cannot transmute. Why don't you shut the hell up and let me do what I want to do? 18 versus 16 bytes. Did I say 18? 8 versus 16. Will that help you? Nope. I've always seen this error before, and I feel like I was able to work around it. But I just don't know if it's going to let me. Like, I remember running into these transmute problems before, and it was an indication to me that I just probably wanted to try and not do that. Maybe I just shouldn't worry about using the pitch here. I don't know. I might be able to find a workaround. It's just it's tough because it's been so long since I've worked on any of this code, let alone this code itself. It's like a magic eye image. Yeah, it did have like, it had almost like a kaleidoscope effect to it, didn't it? That jacked up glitch that we had. This is, well, what would be the way to do it? It would be to get the raw data out, and then like take the pointer of it. The problem is like we're gonna lose the length somewhere, and so yeah, it's gonna cause a pretty big problem. I believe. Oh no, that works. Okay, so maybe I just didn't want to take the raw data. Yeah, because that'll give me a new length, which should be correct. So maybe this is fine. Let's just go for it and see. How did I make it worse? That is so much worse than it even was before. Oh no. What a tragedy. Let me see here. Yeah, so he gets this to become a U8 and then indexes into it by the source offset. The rest of this looks fine. We didn't change anything about the destination, did we? Get into the memory at the destination offset, which is set to the min x times the bytes per pixel plus min y times the buffer pitch. Yeah. Yeah, I feel like the rest of this should be correct, but clearly, you know, it's like I said, the fact that we're dealing with slices and the way that I read the bitmaps in to begin with was just all kind of a little bit different enough from the way that he was doing it that trying to make this change is just causing me some grief. I recently learned that magic eye images were used in school textbooks. You know, that sounds right. I mean, I'm not even totally sure what you mean by magic eye. I kind of want to look this up now. Oh yeah. I feel like I've seen this before in a textbook when I was a kid. That looks so familiar to me. I don't know what textbook I would have seen it in. I feel like I can remember looking at that image in a textbook when I was a kid. They'd have two pictures of a protein in biology in a biology textbook, and you could see the protein in 3D if you looked at it right. That totally sounds familiar to me. You're giving me deja vu bringing this up. But anyway, yeah, this is messed up, dude. I don't know what to do about it. Maybe, let me see here. So the source row, I see when he casts the source row to the source, so maybe that's the problem. I need to cast both of these. Actually, probably just the source to a U32, because right now we're indexing into it as a U8 slice. So I think that might be the only thing that needs to happen here. We will see. So if I transmute it back, this is messed up. It just seems like this is way wrong, it seems to me. I shouldn't need to do this, right? But if I do this and just treat it that way, maybe we'll be good. Well, we're back to our other magic eye image where things are kind of being drawn right, but still not quite right. So, and it could be because I'm adding this X in. In fact, maybe that's the entire problem. No. Yeah, how's he getting that? Where's that coming from? Oh, because he adds to it at the end. Well, that should be... Actually, maybe it's like that. I'm sorry, this is all over the place. I just take random stabs in the dark. Every single thing I do just gets further away from the result that I want. Yeah, because he's incrementing the pixels by 1 every single iteration inside of this interior loop. And then at the end... Oh, because I'm only changing the index here. Yeah, there's so much stuff going on. Let's just do that, I think. And then... Oh, whoops. Is that right? Because he's doing the pointer arithmetic instead of indexing into things, and so that's kind of what's throwing me off here. Oh no, what it should probably be is instead of incrementing the index, it should be like source row equals source row incremented by the pitch, like this. Whoops. I think that's basically how that will shake out. Source row index declared but not used. Where am I using that? Just get rid of that for a while. I just want to see if we can get it to a point where it's doing what it should be doing, and of course not. Yeah, that's why the reason why all this was written exactly the way it was is because it was to help avoid these bounds checking errors that come up when you try and index to a slice past where you should be. But realistically, if I had written any of this right, I shouldn't be hitting those bounds checks. It's just what a messed up place we are winding up in here. I guess I really just don't know what the advantages of, and I guess I can leave this around. Doesn't matter. I don't know what difference it really makes if we're using the bitmap pitch instead. I guess because it has to be, because it's not going to be off of the buffer. So yeah, this, I have to get this working if we want it to, if we want to move forward. But I don't know. Maybe the thing to do here is to just let Casey do his thing and then call it good. Because I don't think I'm going to figure out what I'm doing wrong here. It seems right to me. We get into the offset after setting the or converting the bitmaps pixels to a U8 slice. And so that should be at the correct place. But then this here, well, yeah, there may still be a way to get this to work the way that I had it working before, just a little bit more closely. This gets us back to, what the hell? Oh, whoops. This gets us back to our magic eye image. Well, still not quite right. But the answer is in there somewhere. I might just go forward because we're now pushing 2 hours. I had no idea that today was going to be this much of a hassle. I should have come better prepared, but you know what? This is kind of why I feel the need to change the format of the stream up anyways, is because I want to be able to just get to the answer and then explain it and have that be the topic of the stream rather than watch me just throwing shit at a wall and hoping that something sticks, because this is not very productive right here, what I'm doing right now. Yeah, because this is indexing into this like it's a list of U8s. It needs to be indexing into it like it's a U32. So let me just go back to that, and that'll get us, I think, to the point where we were just a minute ago, where this is. Nope, that's still very wrong. I thought I had this working. No, I think I have to take that out. Nope. Man, what a disaster. Okay, let's just back this out. Hopefully when I come back after the new year, I'll have something that works. But for now, this is just spinning my wheels at this point.
Nothing weird going on there. And yeah, okay. All right, so that's fine. So let's go ahead and step through and see what...
And I forgot that I went... Yeah, so back to where we were. This is going to be, I'm just going to comment it out for now, but this is going to be also a bitmap that we are drawing into, right? Not a bot map, a bitmap.
Do loaded bitmap buffer now, right? And then, and then in here, when we do memory, what I can do is just change this to memory, and now everything lines up properly. They're exactly the same. So let's do pixels to memory. Anybody else? What?
So if I go here and change this to memory, I guess that's all we're doing there. Pixels, all of that can be changed to memory. Any other places here? No, looks like that's good. And I guess I can just go ahead and do the same thing. And there is no bytes per pixel. We'll just use the constant. And then this is just dead code anyway. I can get rid of that.
Is that complaining about bytes per pixel? Ah, yeah, so this is just going to be this again. And I don't remember why we even had that in here. So I'm going to go ahead and say, you know, can we just remove this entirely? Because it says right here pixels are always 32 bits wide. So I'm just going to maybe just say that that has to go away.
Yeah, that's what I thought. He did have that bytes per pixel on the buffer right here. So if I just get rid of that. Oh, the rest of these still have to have a type. And now over here, this can also be the constant. And I'm not sure where else we're using that. Yeah, that is in the platform code, so I gotta fix that. Oh boy, where's this being set? Bytes per pixel. Yeah, this is being used in a ton of different places now, so I feel like that's going to cause a lot of problems.
Right. And we could put this.
But that's the back buffer, so that should be fine. What is this? Off-screen buffer. Yeah, that should be fine actually. I was changing the wrong stuff there. Okay. It's just okay, that's all I had to do, right? I see. So now that just leaves updating the draw bitmap calls. Okay. Started getting paranoid about all these changes I was having to make
here as well, right? Something like this, because we really don't ever allow that to vary, and so we should just say that goes away. So that's that. Let's put that in here. Bitmap bytes per pixel. Bitmap bytes per pixel, something like that. Pixels, it's just memory now, right? Bitmap bytes per pixel, and I'll throw that in there. Bitmap bytes per pixel. Keep on going.
Right. So, what the hell? Bytes per, okay, yeah, no, that's good. This is now memory. Okay, so the last of these errors here are just where we're making these calls.
Pixels minus result. Pixels is not a member, that's true, it's memory now. And should be almost done. Draw bitmap, right. So now when we call draw bitmap, right, what we can do is we can just say, okay, everything now takes sort of one of these loaded bitmap things, and when we
okay, draw test ground, we can just change that definition.
We pass it buffer, instead of that buffer that we were getting before, right, where we're calling it here, what I'm going to do is say that buffer is actually going to be, I'll name it something else. Let's say draw buffer or something like that. Draw buffer, like so. Draw buffer, draw buffer, draw buffer, draw buffer, draw buffer, like that. Then I'm going to say loaded bitmap, draw buffer, and I want to make it a pointer so I don't have to make all these be ands. So I'm just going to make a little synthetic one here to point to, like so, like that. Again, this is just, I don't feel like making these be ands, have to have ands in front all the time, so I want it to be a pointer. But what I can do here is now just initialize.
Okay, so we now have a draw buffer that is a bitmap. Oh, that's interesting. Can I just do this? Do I have to do what he's doing? The way he's doing it just seems kind of strange to me, so I'm going to try and simplify it.
This to be whatever the stuff was that we were getting sent from the OS, right? Pitch, memory, they're all just exactly the same. And we could even collapse these even further now if we really wanted to. Oops. So...
Okay, so this actually is just going to be like this, buffer, and I'm calling this a frame buffer width. We have the height, we have the pitch, and the memory. I see. Cannot assign that to that. Oh, I guess that's true, huh? Because that is U32 from a U8. So can I just transmute it? Like that? It looks like that works. Yeah, I see where he's getting at with not wanting to pass all of them by reference, but you know what I should do now that I'm looking at this? Let's just say that it is a pointer, and then we'll just dereference it so that I don't have to do all those pass by references, and then that looks good. That looks solid.
Ooh, draw rectangle, same thing. That can just be a loaded bitmap now.
And the same thing with the draw rectangle call. Yeah. Change that to a bitmap. And now there should just be a few other places. What is this line here? Oh. Unneeded transmute. Okay. Yeah, because it's already pixels. I guess that's fair. Oh, and then there was another place where I was using pixels instead of memory. Just work through these one at a time real quick. And then we're doing the same unneeded transmute right here, apparently. Almost there. So then if I just drop all of these in, there might be one more call, 1373. Okay. That stuff is all relatively easy to deal with, at least. And of course, we are seg vaulting. So
and the name loaded bitmap doesn't really make a lot of sense. That might be something we want to change in the future. Bytes per pixel is now not a thing. And so off we go. Here's our game still rendering properly. And so now if we do want to cache something, we've set ourselves up to do that. So for example, I mean, you can see how slow this is running right now, right? Like look at that frame rate just chugging along, and all of that's in that stamping, really.
Oh man, such a bummer. Whoops, I did not mean to do that. This is pretty messed up because now I don't even know what's causing this whole thing to crash. It seems like the rest of it should have worked out to where we were still getting our like broken thing loading. You know, it should have run at least to the point where we could see that everything was messed up, but now we don't even get that much, so that is unfortunate. Like nothing else really changed, right? Just other than you know, replacing everything where it was just writing directly to the frame buffer, but doing so like through a pointer to it. Yeah, I don't understand why that had to go the way it went. I wonder if I just walk this back, if it'll honestly just work. Probably not. Yeah, and then over here, I would have to, I think it was just times width, because it's kind of doing the same thing, right? Like, I just don't understand what the point is of doing all of this, really. Just looking at this now, the math works out the same way, so yeah, whatever that bug is, maybe we didn't need to do any of those changes before, but now we have a new bug with this draw code changing that doesn't really make sense to me. Such a tragic way to end the year, but whatever.
So now if we wanted to cache that, when we draw test ground, right, when we actually do that draw test ground function, if instead we just did that at init time, right, we could do that at init time now if we wanted to. So when we do this, we could say draw test ground, and we can draw that into some kind of a buffer. Just to give you an example there, let's say we do game state ground buffer like this. We're kind of running out of time here. Maybe we'll go just a few minutes over. I think we have 2 or 3 minutes on the clock spare. I didn't start right on time. But if I come in here to game state, and I say, all right, we've got a loaded bitmap that's just the ground buffer, you know what I'm saying? And so let's go ahead and do that. Then all I would need to do is this ground buffer thing would just have to be like make, you know, empty buffer or something like this, or make empty bitmap. And I just want to make an empty bitmap that's some size of something. Who cares? It's 1024 by 1024. I don't even care at all. And we just need a place to get that from. And so that can come out of, we haven't really talked still about, we still have And so that can come out of, we haven't really talked still about, we still have kind of a big old standing to do for world arenas here. So, you know, it'd be nice if we at some point actually started to get these arenas into more shape. Something we have to do pretty soon. But anyway, if I wanted to, I can go ahead and still use that game arena for this and say, let's see here, say go ahead and use this arena. Get me one of those and give it back, and then we can draw it into that ground buffer. And then when we come down here, I'll just re-enable this call so that we're basically on top of it. We're going to draw that ground buffer, and we'll draw it at I guess 0, 0 for now. Now, I mean, we don't really know. I guess we would draw it at something, you know, an offset that was.
Okay, so in here, we're still going to do that draw rectangle, but rather than do, what was that before? That was the backdrop? Yeah. Right, because we swapped to drawing the rectangle, right? Yeah, okay.
You know, I guess we would draw it at something, you know, an offset that was proportional to the difference between heights. So I could even do this to do, Casey, draw this at center. But that's basically all we would need to do, right? So here we go. Let's do that. Let's make this make empty bitmap. That's going to return a loaded bitmap struct that has the information about the bitmap that was created. We've got our arena here that we want it to allocate from. We've got the width and the height. So there's the width and the height of that buffer. 1024 by 1024 may have been a little bit large. That may have been a mistake. So maybe we want that to be like 512 by 512 for now. So we'll just take a look at that. And we'll go back to make empty bitmap there, make empty bitmap, and implement it. Now the question is, can I implement it in 2 minutes, which I think is our 3 minutes, which we had left. It seems plausible. You never know. So here's that result. The result has a width of width. It has a height of height. It has a pitch of whatever the pitch is times the bitmap bytes per pixel, right? And then it has memory that is going to be, oh, and you know what I just realized? We can even use this call, now that I think about it, to clear it. So we don't have to clear it ourselves, which is pretty funny. I don't know if we really need that. We could just, do we have a 0 size call? We do. So we really only need that 0 size call, so never mind. So we do have a 0 size call, so we just want to 0 that memory out. So we'll just say total bitmap size, and this will be an arena push where we're basically saying we want to push. Well, you know what? This is just a direct push size, like so. That's all that is. So we're going to say take the arena that we were passed, do the total bitmap size, and of course we know what the total bitmap size is. The total bitmap size is just the width times the height times the bitmap height per pixel, right? And we could use the pitch for that if we wanted to, but you know, if we set the pitch to negative or something, then that wouldn't work.
Just need to get caught up with him here, because this is just slamming this in at the very end, trying to wrap things up. And what was that? That was the memory is. Oh, that needs to be a. Whoa. How hard is it to spell words? So this is going to be. Is it a pointer that he's bringing back? No, it's the actual thing. So this. Yeah, it's going to be a slice of U32s. And that's the size, and we should be good there. Yeah.
So that makes an empty bitmap that we can draw into. It's basically doing the same thing that we did way back at the beginning of the series. Oops, what did I do wrong? That should return, that was right, wasn't it? Yeah, I don't know what's going on there. All right, so let's see. Okay, so we ran out of space in our memory arena. Oh, why is that so huge, though? Did I compute that wrong? Width times height. Whoa, what did I type in? That's too large.
Okay. So make empty bitmap. Guess it takes those dimensions, and then this should probably be a reference, right? Okay. I think we'll at least compile, you know, wrapping up the stream, but it's obviously not working. Whatever I did was pretty messed up, but it's okay. It's probably not super crazy, whatever the changes are that I need to make, but it's just not going to be obvious to me looking at it here on stream, trying to figure it out in any sort of reasonable amount of time. It's probably going to hit me the second I take a break here for lunch.
That's too large. All right, so not quite there yet. I don't see our bitmap, which is not a good sign. It was supposed to work. It didn't work. Let's take a quick look and see if we can find it. So we're drawing our bitmap now into that buffer. And we are hoping that it works properly. Ground, buffer, yeah, like so. And then we are actually drawing it, yes, in here at 0, 0. And I don't know. I don't know if I will have to delay debugging this because who knows? I don't know how complicated the bug might be. I don't want to go too far over time. I'd like to make sure we have time for questions. But yeah, I feel like that should have been sufficient. Unless I'm missing something. We are definitely drawing into. We are not like woefully drawing outside the boundaries of this guy, and we know that because. Oh well, you know what it could be. It could be that we don't have a big enough bitmap to cover where the ground actually was, or something like that. But I don't think that's true because it uses the center. Does it not of the actual? Yeah, it uses the center of the actual screen there. I thought meters to pixels minus bitmap center. And where is bitmap center? Bitmap center is defined here. In fact, we could pull that out to there. Bitmap center, like so on. Oh wait, no, never mind. That's not the buffer center. This is the screen center. So there's that screen center that's using. So that seems like that should put everything at the center of the bitmap nicely. So I'm not sure why we weren't getting anything there. It would be nice to see why that is. Oh, I know why. It's right here, people. We're never setting the alpha channel, right? We're never setting the alpha channel. We've got to set the alpha channel of our composited bitmap. Otherwise, it'll just think that it's basically marked as not being there, right? So there it is. And now you can kind of see that we got the acceleration kind of that we were expecting there. It looks like that we've still got some kind of bug there. You can see down in the corner, like that should not be a notch, I would think. So we kind of have we got something. Although you know what that probably is? That's just because nothing ever touched there. So that's still alpha 0. So what we probably want to do here though still is just go ahead and fix the fact that we instead of always having that alpha.
So I think what this will mean here is that we want to set the well, no, if we just carry the source pixels alpha channel over anyways. Yeah. I guess I don't know about this. That change that he made. I guess I'll just comment it out here because this is. There's no way I'm gonna get to see whether this is gonna work by the end of today's stream.
What we might want to do is write the alpha actually into the buffer. Of course, the problem with that is we actually need to think about what the A value actually should be, right? Like what is the alpha that you actually would write in there, and that's probably a topic better left for a different day. So let's do that tomorrow. To do Casey compute the right alpha here, still have to ever talk about pre-multiplied alpha, but when we do compute the right alpha here, that'll go there, and then we can go ahead and actually do this for reals, where we do something like that and write an alpha channel out. So for now, what I'll do is I'll just say, okay, we'll just take the alpha of whatever the thing is that we're writing, you know, just the actual alpha channel itself, but that's not correct, and so maybe tomorrow.
Interesting. Let's see, takes the alpha, yeah, right out of the source. Oh. Man, I don't know that this could have gone worse. But that's okay. So that's just going to be that, and then this. Let's see if I can do this right at all. This is going to be, well, looking at the differences here. I mean, I guess it's literally just this. It doesn't matter because we can't tell whether it works at all. And then, of course, we're redeclaring or redefining alpha here. So maybe, oh, what's the problem with this? I'll type F32 to a destination pixel, which is okay. So should I just do this? Cast it to a U8? Yeah. It doesn't matter. I can't tell if that's going to do anything correct at this point.
We will do that. So this should be SA, right? Not A, SA. So that should be SA everywhere. That. All right.
Okay, well that explains that. If this is SA, and then this is A, equals, yeah, let's just say that. That is that, and that is that. Okay.
So I think that's about it.
Whoops, I did not update all of these. There we go.
That didn't work. What did I do wrong there? What did I do wrong there? We did SA, we grab SA, we take C alpha, we did all that. We grab the A equals SA, we do the blending based on SA, negative SA plus SA, then we write in whatever the source alpha was. You went 32, A plus 0.5, we cast it back down, we shift it up 24. That should have been fine, right? Let's just double check. 1.0, oh, it's 255.0. Ah, duh. This is actually, yeah, so we'd have to multiply it by 255 because we converted the alpha to be 0 to 1 because we wanted to do the blending, right? We wanted to do lerps all through here. So yeah, we deserved that. So you can kind of see if I put the alpha in there, then you can see if I just use whatever the source alpha is, I get whatever bitmap got stamped down last is the one that shows through. I mean, I could do something a little cheesy, but I could do something where we just take whichever the maximum one is, right? We could say, oh, you know, the destination alpha, whatever was in that, you know, the target buffer originally. We could do something where we basically say, like, you know, whatever the maximum value is out of these two, that's the one that we'll take.
This is all sorts of messed up, man. And I don't even know that this is gonna work. Well, yeah, maybe it will. So this is just getting the destination alpha out now. Yeah, hopefully this carries over. I don't see why it wouldn't, but again, I can't tell at this point.
We could do something where we basically say, like, you know, whatever the maximum value is out of these two, that's the one that we'll take.
Okay, so it's gonna be, man, the max of the destination alpha and that multiplied out source alpha plus 1/2 gives us the alpha channel. I think that looks right.
But again, we should really go through it and do it more correctly. So you can kind of see it's starting to get a little more correct now, but still not quite right. Yeah, and there you go. So that's, you know, that's just the beginnings of how we might cache that. And now our frame rate is back up to normal, which is nice, even though we're doing all those things because we only did them once and now we're just reproducing them. And you can kind of see I didn't really do anything, you know, ignoring this, which of course, like I said, we ran out of time. We could cover how we actually want to do that destination alpha. So ignoring that temporarily, and maybe that's what we'll do tomorrow. We'll talk about that a little bit more completely. ignoring that for now, you can see how simple it was for me to do this. Basically, all I need to do is collapse those two things down so that the thing that we read from and the thing that we write to are handled symmetrically. And that's a pretty important thing to get right. If if you can, you want to be able to draw into stuff that you draw from, because that's what allows you to cache, right? If I have all these things that are taking lots of bitmaps, collaging them together to produce the ground or whatever, and I want to be able to simply take that code that was working when it was drawing to the screen and make it so that it works when I'm drawing to something that I will save and use later as a composite. You want all of those routines to be as symmetric as you can make them, so that you can always sort of switch between which of those you're doing without having to make it this huge deal, right? And so that's something that is a good thing to know. So as we build our renderer in the future, that's something you really want to do. And obviously, graphics cards support this now. With render to texture is what this is, right? It's like allowing you to render into something that you then use the texture from. That's exactly what we just did, right? And you can see that was very simple to do. All we had to do was make it so that we could use a loaded bitmap struct to point to be a desc or a source, and because they really all need the exact same information. How big is it? What's the pitch? And where's the memory at? That's all they need. And so off you go. All right, so let's go ahead and go. Let's go ahead and go to the Q&A. Right.
Okay. Well, if there's one thing that this stream has done for me, it's that it has reinforced the need to do something a little bit different with the format. We had it pretty easy for a while with just like very silly bugs that came down to copy paste. But this is a case where like I don't even know if I'm, translating the code into Odin correctly at all. We've got some messed up stuff going on with indexing into these slices for the source bitmap and the destination bitmap, which just points to our buffer that we want to draw out to the screen, right? That I'm clearly doing something wrong there, and it's causing a seg fault. If not there, it's somewhere else, maybe down where we load the bitmap. I could be doing something. Although I don't think we really changed anything about this code. Yeah, all we did was this and add this pitch, which, yeah, that calculation is the same thing, basically. That we were doing here before. So, yeah, I got to figure that out. I think if I fix that, we'll probably be good to go. And that's my goal before the next stream, is to get that working properly so we can be in the same place as Casey heading into the new year. And then also we'll cover day 83, which is going to be pre-multiplied alpha. So it's like the perfect, segue into doing more of the rendering stuff heading into the new year. It would have been nice to go out on a brighter note. But realistically, now the goal is for me to come into, for each stream from this point on, I want to come into the stream having the code for the next day running fine, and then I can basically retrospect the struggles instead of going through them live, right? Because then that's going to be hopefully more useful for me, both to like, kind of rubber duck what went wrong and appreciate better what I had to do actually fix the problems that I was seeing. And then it also keeps the streams down to a more reasonable length. So they'll probably never be too much longer than an hour after today. And sometimes may even be way shorter, depending on how, much conversation is happening and how many things I decided to do on stream to experiment with the changes from the previous day. So it's basically going to become like a sandbox for me to like get through each new day of Handmade Hero, and then experiment with the things that were done that day, play around with, maybe adding some actual gameplay elements on stream. I don't know how that's going to look, but it's going to be different. But I think it's going to be fun, and it's going to be there's going to be more output for the actual stream versus just like, me being grateful that I got through it every single time, because we haven't had a day like this in a while where it was just like, oh man, everything is going wrong. But that's okay. It means that there's an opportunity to learn something. And like Devil said, that just means we have an early New Year's goal. Yeah, my New Year's resolution is to start off, do the first stream in 2025 with a non-crashing game. So thanks for hanging out with me for another stream. I hope you have a good rest of your 2024. I'll be back not this Friday, but the Friday after, which I mentioned it a few times, but I'm pretty sure that's the 3rd. Yep. So I'll be back next Friday for the 3rd, where we'll cover day 83 of Handmade Hero and Odinmade Hero. So yeah, take care, be safe, and I'll see you in 2025.